Let's explore some cost applications of linear functions. So our first one, we're looking at a bank charging us a monthly fee of $2 plus an additional charge of 5 cents for each transaction. So I'm looking at moving to another bank with a different cost structure. I'm asked to write a linear model using CX. Now I want you to notice, and again I'm going to put current bank here, so as we go we know I'm dealing with the current bank. CX means that cost, C, is a function of X, where X represents how many transactions that you have at the bank. So we're writing this in a function format. It's important to keep it whichever way you're asked to in the instructions, make sure that you use that same letter. So if it said for the first bank use B of X and the second bank use T of X, then make sure that you're doing that. Here it says my current bank charges you $2 per month plus 5 cents for each transaction. Now notice it already tells me that X is the number of transactions, so it would make sense that I would be taking 5 cents times X. So my cost structure per month at my current bank is $2 flat fee. I'm not going to multiply that by anything because it's just flat fee every month. And I'm going to add to that my 0.05, which is 5 cents, times the number of transactions that I have. So that is my current cost structure. Now it says I'm considering moving to a new bank that charges no monthly fee but charges 20 cents per ATM. So for my possible new bank, the cost based on the number of transactions is 0 flat fee plus 20 cents or 0.2 times X, which of course could have just written as 0.2 times X. It says write a linear model representing your cost each month at each bank. So that is what we have just done. When it says to write a model, it's saying write a model using X or Y or T or whatever variable they're asking you to use, so that down the road, which is going to be in a second or two, we're going to plug in a value for X to see what the solution is. So that's the first part of my answer, is to write the linear model. Then it says use your model to determine the cost of each bank for 18 ATM transactions to determine if you should switch banks. So we're saying we use 18 times a month the ATM. Is it better to switch banks? So how are we going to do that? Well, I'll keep with the same color scheme. For my current, I'm going to take C of 18. Now when I write it like this, all that means is every time I see an X in my equation, I'm replacing it with 18. So don't take C times 18, because all this is saying is that it's the cost for 18 transactions. So I'm going to take 2 plus 0.05 times, replace it with 18. So 0.05 times 18 gives me 0.9, so it's 2 plus 0.9, or $2.90. So at my current bank, I'm spending an average of $2.90 per month. The question is, would it be better, based on 18 transactions, which is apparently my monthly average, should I switch banks? So for my new one, I'm going to take 0 plus 0.2 times 18. So 0.2 times 18 is 3.6, so I have 0 plus 3.6, which of course is 360. So for my current bank, I'm paying $2.90. For my new bank, I would pay $3.60. What's my conclusion? Again, I would write a sentence. My conclusion in words is that I would stick with my current bank because it's 70 cents cheaper than switching to the new bank. So here's another question for you to try, and it's very similar to the last one, but there is a little bit of a difference. But I would like you to press pause and try this question, and when you're all done, press play to check your work. So here I'm dealing with fast signs and sign me up, which is super clever. So I'm dealing with two different cost structures for signs. So for fast signs, I'm going to use blue. And fast signs wants me to write a cost function C of X. for X signs where it charges $1.20 per sign. So that's pretty straightforward. $1.20 is 1.2 multiplied by the number of signs because it says per sign and X is the number of signs. My sign me up, which I'm going to do in green, sign me up. My cost structure, C of X, is equal to $1.10 per sign plus a one-time setup fee of $15.90. So 1.1x would be how much I pay per sign plus a flat fee of $15.90, and notice I'm not going to take that times x because otherwise it would be like $15.90 per sign, and this tells me that it's a one-time fee only. So for the first part where it asks me to just set up the models, those are my two models. Notice they're both functions, so I didn't just write 1.2x, I wrote C of x equals 1.2x. Then it says, determine the number of signs for which the cost for each company is the same. Now on the last one, they specifically said plug in 18 because that's your average. Now we're saying, hey, let's go ahead and look at, which one's better for all of the different numbers. So if I want them to be the same, obviously I would want the cost for fast signs to equal the cost for sign me up. So all I'm going to do is replace the blue with 1.2x. I'm going to replace the green with 1.1x plus 15.9, and then I'm going to solve. And when I solve, I'm finding the exact number of signs, x, for which the cost is the same. So if I subtract 1.1x from each side, I get 0.1x equals 15.9. If I divide each side by 0.1, I get 159. So technically I've answered the question. The question says, at which point is the cost the same? X 159, I would write my sentence, the cost is the same at 159 signs. But let's take a look at what this would look like, or why this works, or does this even make sense? If I were to graph this, my cost function for the first one would start at 0 and have a slope of 1.2. And we haven't talked about graphing yet, but you learned it in your last course. But again, this is not an accurate graph. I'm just giving you an idea of what this would look like. My other graph would start at 15.9 over here, and the slope would be not quite as steep because it's 1.1 instead of 1.2. And again, it would kind of look like this, and at some point it would cross, and that's what we just found is the point at which it crossed at 159. Now, obviously this is an ordered pair, so if I took C of 159, that would be 1.2 times 159. And if I take 1.2 times 159, I get 190.8. And just for funsies, let's go ahead and verify that that number should be the same for sign me up. So 1.1 times 159 plus 15.9. So 1.1 times 159 is 174.9 plus 15.9. And if I add that, I sure do get 190.8, which means this answer is 159, 190.8. Well, that's all well and good, but what does that mean in the context of the question? Because that's the most important thing. What I've just found is that at 159 signs, the cost for each company is the same, and that cost is $190.80.